Hello there and welcome to another lesson with Mr. D. Your teacher here, Mr. D. You should be very familiar with these. I'm probably going to start just getting straight on and not giving you lots of spiel about me talking and talking and talking. I'm sure you're sick of hearing my voice these days. I've heard that I have a pretty annoying voice, perfect for being a teacher and nagging. So we're going to carry on with some maths today, and we're going to carry on doing some equivalent fractions. And it's been a bit quiet, so hopefully people are just getting their heads down and knuckling down on this one because it does take quite a lot of focus. Before we get into the lesson today, I just thought I would just recap some of the other places to find the work, just to make sure that people are doubly sure about how to use the Google Drive, where to look on YouTube for the videos, and how to keep the work organized, because now there's quite a lot of videos and there's quite a lot of work. We need to work together to kind of keep that organized so people know where to look for stuff, and I'll do a bit and you guys can definitely do a bit too. So as you know, I will put all of the lessons and record them and put them straight onto YouTube. They'll be there every single morning. There'll be a new lesson. There'll be definitely two, literally a maths and sometimes a topic or a science. I'm trying to do something a bit of a surprise as well. But there'll always be some videos on YouTube. So if you wanted to bypass DB Primary when you start doing your lessons, you could head straight to YouTube onto the channel, and you will find the lessons straight away there. If you are, if it's hard for you to do that and you don't have the channel subscribed, or you don't know what that means and you're going through DB Primary each day, I can show you what that looks like a little bit. So let's see if it stays logged in. Good. So this is my teacher DB Primary, and good for you. I manage all of the messages and the mail, and I can see what you guys are talking and saying as well. So please only use this for work purposes. I'm fine if you guys leave blog entries, but please just keep it school related. Remember, I can see everything, and if I can see everything, that means Mrs. Kenny can see everything as well, and Miss Earl. So here you guys all are, all of year 3. I'm going to go into, not going to do anything, so I can see your profiles. I don't do anything with them, don't worry. So this is what Danny would see, and when I send him a message, he could just go into read his mail or the mail section, and my messages would be in there, and he would open that up. I'll do that on mine, so hopefully yours looks a little bit like mine when I go into my messages. And you'll see a message from me. It'll say from Mr. D or Mr. Davis, and there'll be a subject there about lessons, and then the links will be on there. I'll go into my sent because you'll see it from there. Internet's rather slow. Here we are, lessons of week 3, W3, week 3, lesson 2. There'll be a subject like that, and all the links will be there. So this link will take you to YouTube, the lessons, and this one will take you to the Google Drive, which we'll go into next. And so you'd click the link to go into YouTube channel, and then hopefully the video would load up. There's me, there's me and me. And from here, what would be quite good to do is to go into the channel here. That's the channel there, and then you can subscribe to that, and that way you get all of the notifications. Also, what I'll start doing is in the description here, I'll start putting links to the Google Drive and extra worksheets that are attached to this lesson.
Using the book today as well. Hopefully you've
so
done
then
the characterization of the farmers.
You could go into the Google Drive from the video, or you could go from the mail. I've gone to Google Drive here, giving you a link. That should take you to the Year 3 section, and it's pretty well labelled. So if you were doing numeracy, which we are doing now, you go to the numeracy folder, and all the work should be there. I'll try and label things with the same lesson. So if it's week 3, lesson 2, I'll try and label the worksheets week 3, lesson 2, and you'll see in the video title here what lesson you're on. So yeah, and then I'll just go through a couple of things that are on here just to check that you guys know what you're doing, because I put extra stuff on there. So we've gone through this pyramid one. Here you're adding fractions together, then 2 adjacent fractions are added together and they make the fraction above it. So those 2 would add together to make this one, and those 2 would add together to make this one. And then to get the top one, you add these 2. The answer goes in there. Some of them you're going to get a numerator, a top number that's bigger than your denominator. We've said that's fine. That just means that you've got a whole and some extra parts as well. This one's another visual for adding. We know that if the denominator is the same, we can just add across the numerators. The denominator stays the same. And here's a bit about, it's got subtraction and adding as well. So if you're adding, you're going to draw. If you're taking away, you're going to start removing some. Again, print these off or work from the screen like I'm doing now. I could just pause the video here and I can just I can copy those in. Yeah, it's going to save paper, save the planet, save on you grown-ups having to print out stuff, because I know printers can be funny. Here's just another representation. It's just good to see these fractions in lots of different forms. Yes, it can be a circle, it can be a square, it can be a rectangle. So here you've got fifths. Here's your whole split into fifths. You could colour in 2 fifths. You could add another fifth. How much have you got all together? Yeah, really try and work on that methodology, showing lots of different ways. Yes, you can add straight across the numerators, we know that, but if you can show your method, it shows real good understanding. Again, this is working to tell me what fractions are being shaded in. So that would be 1/6. This would be 1, 2, 3, 4, 5, 7. 2/3. And there's some of the worksheets that I'll put on as well. What worksheet is that? Worksheet 7. And this is something new that I gave for a challenge. So you've got to look at all of these 3 fractions and use these more than or less than signs. We know that if it's getting more, it's going to open. So look at these 2 first. Which one's the biggest fraction? Which would you rather have, a quarter or 3/4? Well, probably 3/4. And then you got loads here. Well, you can do them for a whole row. And when we get good at equivalent fractions, we'll be able to compare fractions that have a different denominator. That's what we're trying to work ourselves up to. So imagine if we could compare 2/4 and 3/5 when we get good at equivalent fractions. But because the denominator is the same, we can just compare the numerators. The bigger the numerator, the more parts you have, the bigger the fraction. Okay. That's just a little bit on the stuff that we've got so far. We'll get cracking. I'll give you a few things today, so it might be a bit longer, but just pick and choose. If you wanted to skip this whole bit, skip it. A bit late now, I know, but hey ho, I'll do the same for literacy. So skip the diatribe again. Where was I? I'm lost. I think I'm doing some fluency. Yes. Da 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 da. I usually go through these, but I won't do a lot of go through. I'll let you guys do those. You should be pretty familiar with these now. I'll give you some tips. So here, try and not hold the whole number in your head. Try and just add your ones together and then put it back into the whole parts. Here, you're going to do a column subtraction. Okay, you're going to, and remember with column subtraction, this number has to go at the top, your starting number. You're taking this number away from this number. So 138 would go from here. And then when you're doing your sum, you always start at the top and work your way down. 6, take away 6 minus 8. 6 ones, take away 8 ones. Now, can I do that? It's going to be a big fat no. So you're going to have to rename from your tens, and you guys know the rest. When you times by nothing, if I've got nothing and I've got 4 lots of nothing, that's all that's saying. 4 times nothing, 4 lots of nothing. 1 nothing here, 1 nothing there, 1 nothing there, 1 nothing here. I'll have no nothings. Nothing, nothing, nothing. And here they try to fool you a little bit by putting the answer at the front. And that shouldn't fool you, because if you know that this sign means equals, but it also means the same as, then the number sentence still makes sense. Something is the same as 18 times 4. So 18 times 4 is the same as, equals, and also the same as. There you go. Start you guys off. And then we've been doing the 6 times table as well. So hit the button, type that into Google or whatever you're using. We're doing the 6 times table. I haven't had much scores. I think this is, I think people are struggling to beat my score of 20 odd. I think on my first video I did a score of this, so have a go at the 6 times table. Again, remember, if you don't want to do this, just skip ahead to the video to the bit where we're talking about fractions, or if you want to just do the fluency bit, do that. I want to have a go, but I want to get on with the lesson. So maybe I'll have a go tomorrow. Right, equivalent fractions. When we've got our numerator and denominator the same, that's the same as a whole. So they're equivalent. A whole is the same as 2 halves. A whole is the same as 5 fifths. A whole is the same as 8 eighths. When your numerator and denominator are the same, you have a whole. I'm speaking fast, but remember, you can pause. If you didn't catch what I'm saying, just rewind it and watch it again. And then we looked at fractions being equivalent. Those fractions that are the same. So you will have different denominators, but the actual amount that you have, the actual fraction that you have, is the same. So yes, they are 2 different fractions, but in terms of the parts that you'll get the same amount. So we looked at this being 2 quarters, and it was the same as a half. We're thinking about patterns as well. We're going to get on to. Looked at a challenge one, and we'll do another lesson on looking at equivalence and getting you guys really, really confident that fractions can be written in different ways, but they are exactly the same. And I gave an example, didn't I? I'll just go back and I'll show you. I think of it as your times table. If you're struggling to think, oh, how can 2 things be the same and different at the same time? Well, let's think about the number 12 and a times table that has 12 in it. So 1 comes to minus 6 times 2. Are there any other times tables that make 12? What's 4 times 3? 3, 6, 9, 12. That's also 12. Two completely different times tables, but we get the same answer. Yeah, so although quarters and halves are completely different, if we've got enough quarters, we can make a half. Don't know why that's come up there. Why does it keep doing this to me? Right, finding equivalent fractions. Here's an in focus task then. And you guys can do this. Get yourself a strip of paper and try and either fold it or cut it into 3 equal parts. It can be rough, but as long as you know that they have to be equal parts. And Sam thinks that we can write a third in other ways. Is he right? Well, my pen's in a convenient position. We should know he is right because we did do this last lesson. We can split our thirds again, and I've still got equal parts, but this time I've got 1, 2, 3, 4, 5, 6 equal parts. Nothing has changed to the whole, it's only the fraction that have changed. So the green bit is a third, and a third can be the same as 2/6. You have to make sure that when you're splitting it further that you're splitting it equally as well. So what I mean by that is that you couldn't split this here and then not those two, because you could. This would not be 1, 2, 3. This would not be quarters, because these two parts are completely different to these two parts. Now, all the parts have to be equal. That's one of the top tips of fractions. This should be familiar. I'm gonna whiz through this. We know that it's a third because it's 1 part out of 3. The 1 is the numerator, that's how many parts of 3 is the denominator. The line is the fraction line. But what other ways can we write it? Well, I can fold that third again, can't I? And I've got 1, 2, 3, 4, 5, 6. And I know that the third bit hasn't changed. I haven't done anything to it. If you shaded it in, you'll know that you never actually changed it. But you split it again, you've still got the same part here, but a different fraction. So if you cut your paper into 6 rather than thirds, you'd need 2 6s in order to make the same amount. What about 12? 12 equal parts. How are you going to cut your paper? How are you going to cut this 12 equal parts? Well, if you know your times table really well, you know that I've got 3 parts here that need 12. We have to split each one into 4. Split my whole into 12. Now, how many 12s make that a third? Just count them up. Is it 1 12? No, that's that. Is it 2 12s? Yeah, and you could. Sometimes they'll try to trick you, so a bit of a challenge is they might do something like this and shade in parts, but they might shade in like all of those parts there, and then a random part over here, and they'll ask you A. They might ask you A, what is that as a fraction? And B, they might ask you what that is in relation to equivalent fractions. They might, let's say they might shade one here, two there, and then these two here. They might say, is that equivalent to a third? Well, you might think no, because I haven't shaded all of those in. But it's still a third because I've still got the right amount of parts. Equivalent to 12. It is tricky, I understand. So the best advice I can give at the moment is just keep going through it, keep going back to it. It's hard to properly explain over the computer, and I'll try my best. I'll try and do it as best I can. So here I've got thirds. This is the 6, and this is 4/12, and it's showing that the whole is exactly the same for each tree. The bar hasn't got any bigger or smaller. All that's happened is the fractions got bigger, so the parts have got more parts. So here I've only got 1/3. I'm going to need 2 6 to make that third, and 4/12. Hopefully that just makes sense visually. Hopefully that shouldn't be too hard. You should be really, really keen and really, really good at spotting the pattern visually. And we will be moving forward into a more mathematical method soon, and we'll have to start thinking about the patterns between numbers. So then here's a fraction wall, and you're going to do your own in a bit. Here's your whole, here's halves, here's quarters, here's eighths. So this should be easy. One whole is the same as how many quarters? Well, to make it the same, I've got to get 4. We know that the 4 quarters, we've got to get my whole again. I've got to have all of them. But here I've only got a half, so I need to go how these fractionals work. Go to where a half is, that's 1/2. Right, how many eighths? Because that's what I want. How many eighths make a half? 4 eighths. That's easy. That easy. This is. And what about 3/4? Right, go to 3/4. That's 1/4. That's 2/4. This is 3/4. How many eighths? How many? Well, the question could be: can you get how many halves from 3/4? Or you say it's not possible because you can't. You need to have the whole fraction there. And this one here, I'll let you guys have a go on your own a bit first. So pause the video. So I got a bit confused at first about what it's asking because they look like 3 individual questions. So you'd write 1/4. But it's trying to get you to see that all of these shapes are the same. So imagine I've got 3 equal squares. These are different ways that I can split that square and get equal parts. Now you should see that even though they've changed where that blue bit is, if I took that blue bit there and I rotated it, it would fit here as well. So you should see that they're equivalent. So you might be able to think, are they equivalent or are they not? And they are equivalent. So I can't remember if we've done this worksheet or not. I might have moved us on, but do have a go at this. I think we've done it already. If we have done that one, then we shall. Oh, that one's rubbish as well. I just remembered. Why did we do 7 and not 6? I'm talking to myself. Do bear with me. I'll put this one on as well. I can't remember which one we've done. I'm losing my mind being in lockdown. So have a go at this one. If you've done it, or if I have put it on, then I'll put another one on here. Try and put these on. And I'll put some extra challenges on the Google Drive as well. But what you guys can do for me for definite is have a look at this fraction wall. So this is a good way of seeing all the different fractions that are equivalent to each other. So this is your whole, and then each whole has been split into halves, thirds, quarters, fifths, sixths, sevenths, eighths, all the way down to 12th. And you can use it it's quite a good visual tool to look at which fractions are equivalent to each other. So we know that a half, what's equivalent to a half? Well, we know that every time that you can probably use a ruler, every time that the lines match up, you know that you've got an equivalent fraction. So I'm going down from my half. Well, first of all, everything's going to be equivalent to a whole in some respect, just when you've got the same amount of as your denominator. But you can find out, let's say, what's equivalent to a half, or find where 1/2 is, that's here. Follow the line all the way down. Every time you meet a line, and use a ruler for this, right, I know that this lot of fractions are equivalent to a half. They're quarters. How many quarters do I have to get to the line? 1, 2 quarters is a half. I could keep going down. So fifths, you can't get a half out of fifths. Sixths, I can make a half. I can get 6 equivalent to 1/2. I need 3/6 in order to make a half. So, like I said last time, didn't I? So, some of the questions that you might get asked is would you rather 3/5 or 1/2? And you might think, well, 3/5, I know that fifths are really tiny. 3 or 1/2 of a chocolate bar, that's going to be huge. But you'd actually rather 3/5, wouldn't you? Because you'd get that a little bit more than a half. So, again, I'll put this on and you can design your own and colour each fraction in your own colours. But stick that somewhere, because if you ever get confused, this is a good little tool to use. It's a double check if they are equivalent. So for example, how you'd use that, let's say you have the question here, 1/4. Right, well, get what? Right, let's use my fraction wall. 1/4 is here. How many eighths? Well, I follow it down until I get to 8, so it's 2/8. So before we get onto the maths of equivalence, get really familiar with the visual representations of fractions and how fractions are equal to one another. I feel like I've been rambling, but I will put some fraction equivalence questions. Let me find those for you on the line as well. Let's see if we. So you can have a go at some more equivalent fractions here. So here you've got the same whole. Match the rectangles with the equivalent amount shaded and stick each in. Right, well, I'm struggling to see how. Okay, I think I'm there. You'll have to change this task slightly because I don't want you guys doing lots of printing and cutting and sticking. Write the fraction for each one. You can probably use your fraction wall if you want to help you find which one is equivalent. So you can use your fraction wall, or you might be able to see that all of the holes are the same. The whole big rectangle doesn't change. Right. That is. How can I know those two aren't equivalent because they're completely different fractions? Yeah, so maybe that's a bit of a challenge question. If you've got the same denominator, if two fractions are the same denominator, can they ever be equivalent? There's a challenge question for you. If you've got two fractions that have the same denominator, can they ever be equivalent? So you know those two can't be equivalent just by looking at them. So it's going to be these ones, and you can circle the ones that are equivalent. Sorry, middle one and this one. And hopefully you'll see that if I move that little bar up there, I would get the same as a quarter. Again, use your fraction wall, right? I've got 3/6, 3/12, and 1/3. Again, if you're really, really familiar with fractions and you really get it, you'll know that if I've got 3/6 and the denominator is 3/12, then I know that 12s are smaller than 6. I know that those can't be equivalent because 3/6 is tiny compared to, is way bigger than 3/12. But again, use your fraction wall. How would I do this? So 3/6. So go to the 6. 3/6. Is it the same as, can I get thirds? No. 1, 2, 3/6. Is the same as. So those two aren't the same. What about 3/12? I'll do that. I go to 3/12, and then I go all the way up. But it's not that. So what about 6 and 3/6? Are any of those equivalent? Oh. Maybe you've got to. Oh, okay. They're not in. They're not in. They're not in questions like rows. You've got to use the whole, every single fraction and pair them up, a bit like snaps. So you can either cut them out, make your own snap cards if you get really confident, or you'll have to find a way of maybe using colours to highlight the ones that are the same. Or write them all down and then try it. So if you've got 1/4, which one? We've got 2/4 here. Which one is the same as 2/4? Which one's the say there's 2/4. I think it's a bit tricky, this one. I'm cheated there out. Doesn't really help us. I'm going to have a go at the sheet as well, I think, guys. I'm going to try and work it out myself, but there are equivalent fractions in there. I can see them. Oh, there's 1/4 there. 1, 2, 3, 4, 5, 6 24ths. They've got 1/4 there, 1/4 there, 1/4 there, 1/4 there. So 6 24ths is the same as 1/4. It's a bit of a challenge on that one, so I'd stay away from it if you're not too sure. Again, go back through the video and find the questions that are a bit easier, or have a go at the challenge if you want to have a go. Have a go at these questions and fill in your own fraction wall, and just have a look and explore again which fractions are equivalent. Try and get really good at using this, or making your own one, using your own fraction wall. Right, I will leave you guys there. I will stop talking for now, and I will see you next time.